Hello, Augies Worldwide. I'm Dave Kassler, amateur radio call sign KE0OG, here with another episode of Ask Dave. This question actually comes from a comment to one of my videos. The video had to do with using Anderson power pole connectors to make a 12-volt extension cord for that light right there, okay? That light is the light that we used as the primary light for here. It operates on 12 volts, and so I thought, why plug it in when I can plug it into the solar? Let that be light from the sun that's brought in here by magic. Now, a fellow by the name of Tim Dewerson, and I don't know if he's a ham or not, I'm assuming he is, but YouTube doesn't record call signs here. Says, do you have to calculate the voltage drop for the long wire and how much power is lost getting to the lamp? How will that affect the lamp? Well, let's find out. Okay, I think we decided that that cord was about 25 feet long because it has to go quite a ways around a bunch of obstacles to get up over there. So let's take a look at what we've got here. We've got a battery, okay, plus, minus, and we got this comes up to the DC distribution panel. I'll just call it a panel. And then we've got the lamp over here. And this cord comes up here, it's about 6 feet long, would normally plug directly into that panel, but it's too far away. So we created a cord, an extension cord, that comes from here to here. Now, this is about 25 feet long, okay? However, it consists of two conductors. So if we look at this from a circuit point of view, we've got a power source over here. We've got one wire with a resistance here, and this goes to the lamp, comes back over here, and you've got another resistance here. Okay, so 20, what did I say, 20 or 25? 20 feet, okay, 20 feet. In each direction, we've got two resistors. Now we look at this table. This table comes from the Radio Amateur's Handbook. It's table 22.44, copper wire specifications. It's designed specifically for bare and enamel coated wire, but it works for just about any kind. Here's 18 gauge wire, which is the size of the wire that we used. And if we go over here, we see ohms per 1,000 feet at 25 degrees centigrade, which is about room temperature. Yes, the resistance will vary slightly with the temperature, but not very much. We find that we have 6.386 ohms per 1,000 feet. Okay, so let's write this down. We have, of course, 40 feet total. So 6.386 per 1,000 feet. Divide that by 1,000. Okay, and multiply that by 40. And we come up with 0.25 ohms for that. Okay, so we have 0.25 ohms in that wire. And we'll lump that into one resistance. 0.25 ohms, not very much. Okay, and this is to the light over here. 0.25 ohms. Now the question is, what is the voltage that is lost across this? And in normal operation, let's say this is 2 amps. So your voltage drop here, E, which is the drop, I'll put a D there, equals 0.25 times 2. Okay, which would be 0.5 volts lost. 0.5 volts. Okay, now to find the power that's lost, half a volt's not going to make much difference for that lamp because it will take 12 I'm sorry, 12 volt plus or minus about 10%. Okay, and this is well within that over here. Now, power loss, power is the current, well, the voltage times the current. So the voltage is 0.5. The current is 2 equals 1 watt. That is how much power is being dissipated by that 20-foot extension cord, 1 watt. Okay, now even if I screwed up the mathematics here a little bit, we see that it's a trivial amount of power that's being lost in this lamp over there because of the extension cord. As it turns out, this lamp has on the back of it a brightness adjustment. So we just turn the brightness adjustment up to the point where we like it, and I will tell you it is nowhere near as bright as it will go. We change that light for this light. This light looks bigger, looks meaner, nastier, and it sure costs more money, but it's nowhere near as bright as that lamp. So I use this for live streams and that one up there for recording videos. So that answers your question there for Tim. Do you have to calculate the voltage drop for the long wire? It's about 0.5 volt. And how much power is lost getting to the lamp? 1 watt. Okay, that answers the question. That is a perfectly acceptable extension cord. Now, would I use an extension cord like that for a radio? Okay, if instead of 2 amps, I put 20 amps through that cord, you'd have a very significantly higher voltage drop. You'd have 5 volts dropped. 5 volts dropped. Now, going from 13.8 minus 5, and you going, oh, that's too low voltage for the thing to operate. So you have to keep in mind the wire size when you're building something, you know, for a simple little light like this, which is an LED light, and it takes very little power. 0.5 volt drop, no problem. 5 volt drop for the main radio, problem, okay? Which is why we put the power supply right next to the radio, and we use nice fat 14 or 12 gauge wire for that. So there you have it, a simple application of Ohm's law. If you followed this far in the video, please subscribe and click like and share this video with others. This is a great example of the implementation of Ohm's law. And until we next meet, 73.